What's up, guys? Welcome back to the next video in learning Java. My name is QDS Danny and you guys are watching my channel Wood. Alright, so we are very excited to say that we start the Java virtual machine. What is Java virtual machine? As we already know that Java is both compiled and interpreted language. Java can be run on a wide variety of computers and devices because it does not execute instructions on computer directly. Java source code is turned into simple binary instruction just like a machine code. C and C++ source code is reduced to native instruction for a particular model of processor. Java source code is run on the hypothetical computer known as Java Virtual Machine, our JVM. When programs called JVM, it means it is not a physical from hardware, it is only a software. Compiled Java bytecode is executed by Java Runtime Interpreter, compiles to bytecode instead of machine language. Okay, so as we seen previously that Java is both compiled and interpreted language. We already seen what is compiled and what is interpreter. Why Java can be run on a wide variety of computer devices, because it does not execute instructions on computer directly, because it's not going to go straight away on making object file or making linker or going directly to assembly language. Our machine languages, it is looking for there is something called JVM, Java Virtual Machine. Java source code is turned into simple binary instructions just like a machine code. So C and C++ source code is reduced to native instruction for a particular mode of processor. That's what when it comes to write, say for example operating systems, we use the C and C++. When you guys writing the specific architecture, then if you are thinking it's very hard, then you can go for assembly language as the old time people used to, and then you can go for their third option is C and C++. Say for example Linux is very popular in the world. All the supercomputers running Linux, even NASA and even Pentagon, even everyone uses Linux because Linux is open source and is very fast. See, your Android phone is very fast because it's in Linux. So the Linux first came in and the guy wrote the Linux in assembly language, and then he thought the assembly language is very complicated, so why not I'm gonna write the entire program, my entire operating system in C and C++. So you can, as we said, that you can write operating systems because operating system goes with the architecture of the computer. You can write it in C and C++. When you need the native instructions, for example, of that particular model of processor, you need to go for C and C++. And the Java source code run on hypothetical computer known as JVM, or Java Virtual Machine. So what is Java Virtual Machine? And the interpreter is Java Virtual Machine. So there is another word for interpreter is JVM, or Java Virtual Machine, because that interpreter is not bound by any architecture, but the compiler, because the compiler compiles the entire your code, it needs to be written inside the C and C++, and it goes for a native instruction. If I tell you to write a game for me, or write a mobile phone for me, that is going to be very popular for every architecture, then you're not going to go with C and C++ or assembly language. You're going to go with Java, because Java is because you're going to know that if I write this code once, I'm going to run it anywhere. That's all. Write once, run anywhere, Vora. If you remember from the first video, we put a WORE, Vora, write once, run anywhere. And when programs called JVM, it means it's not a physical from hardware, it's only software, as in the case of the interpreter. Compiled Java bytecode is executed by Java Runtime Interpreter, compiled to bytecode instead of machine language. So the Java compiles everything into bytecode. Java, they don't go for machine language. So the Java source code is compiled into universal format. So in that instruction, what we call is JVM, or Java Virtual Machine. So now we're going to see the Java Runtime Environment. That's our source code, hello.java, and we use the compilation. We compile it, and our Java C hello.java. This guy is here. Then we go Java Runtime. It's going to go on Java Runtime as the previous ones. Your source code after the compilation it turns into the bytecode, and that bytecode is Java runtime. So the compiled Java bytecode is executed by Java runtime interpreter, as this guy is here. The Java C hello.java executed by Java runtime interpreter, which is this guy is here. The runtime system performs all the normal activities of a hardware processor, but it does so in a safe virtual environment. It executes a stack-based instruction set and manages memory like an operating system. It creates and manipulates primitive data types and loads and invokes newly referenced blocks of code. Most importantly, it does all this in accordance with the strictly defined open specification that can be implemented by anyone who wants to produce a Java compiled virtual machine. And both of these, the virtual machine and language definition, they both provide a complete specification. And keep in mind that this Java interpreter is very lightweight. It's not very heavy, and it's very small. Also, it can be implemented whatever form whatever form you guys want, whatever form you guys desire in a particular platform, in any platform. So your interpreter may be run on a separate application, or it can be embedded in another piece of for example another software. For example, if even it's going to be the web browser. And as we said that if you think all of this together, it means that the Java code is portable. So now we're gonna see that our Java runtime or bytecode interpreter, as we say, that is going to be compatible with every operating system. Say now you're going to go on the Windows, and the next operating system is going to be in Linux, and the next guy is going to be the Macintosh. So what we see in this diagram here is our source code is going towards a compilation. It becomes Java C hello.java, and the compilation turns our Java source code into Java runtime, which we call this bytecode. And the bytecode, it's a platform independence of, it can run on any platform. So if you don't have to produce alternative version of your application for different platforms, and you don't have to distribute source code to end users. And keep in mind that the fundamental unit of Java code is the class. As the case with the other object-oriented languages, the classes, which we say OOP or object-oriented classes, are application components that hold executable code and data. And compiled Java classes are distributed in a universal binary format that contains Java bytecode and other class information. And classes can be maintained discretely and stored in files or archived locally on a network of server. Classes are located and loaded dynamically at a runtime and as they are needed by the application. So we're gonna go on Java runtime architectures, and we're gonna go see that how the Java, if you look in here, that there's a computer hardware here, and the Java virtual machine sits on top of the computer hardware, and on top we have core runtime libraries, and on the top is the Java bytecode sitting here. So if you look in here, the Java virtual machine, which is you can say that's interpreter, sitting on top of the hardware. They are not inside the hardware, or they're not like a compiles. It goes and manipulates in zeros and one, because that's a Java bytecode, Java virtual machine. So keep in mind, interpreter is nothing but a virtual machine. Virtual machine is just like it's say for example, if you have a virtual box, when you use a virtual box is like a computer within a computer. So when you want to use say for example, if you are downloading the virtual machine or virtual box, you can run another operating system inside that virtual machine, because that virtual box is just like your normal operating system. So that's just like your computer. The same goes with the virtual machine. Virtual machine is just like another machine, so it mimics the behavior of another machine. It has all the goodness of the another machine, but because it's a software, that software, the virtual machine runs on the top of the hardware. So it sits on the top of the hardware, and on top of the virtual machine sits all the Java core runtime, and all the libraries sits on top of that one, and on top of that one sits all the compiled bytecode. As we've seen already, the compiled the bytecode, how Java executes this code, and how Java after the compilation becomes the Java bytecode. And that bytecode runs on any platform, say be it Windows or Mac, or be it on Linux. As we say that interpreters are very slow, but Java, as we said, that its interpreter language is its compiled language. So compiling source code down to portable bytecode, Java has been carefully designed so that the software implementation of the runtime system can further optimize their performance by compiling bytecode to native machine code on the fly. This is called JIT, or just-in-time, or dynamic compilation. So with the JIT compilation, Java code can execute as fast as native code and maintains transportability and security. You guys are gonna hear the JIT a lot, but as we said, there is two sides in a coin. The problem with the traditional just-in-time compilation, or JIT compilation, is that it optimizing code takes time and it's slow. So a JIT compiler can produce decent results, but may suffer significant latency when the application starts up. And to solve this problem, Java's compiler technology is called hotspot. Uses a trick called adaptive compilation. If you look at what programs actually spend their times doing, it turns out that they spend almost all their time executing a small part of the code again and again. So the adaptive compilation also allows that the Java runtime to take advantage of the new kinds of optimizations that simply can't be done in a statistically compiled language. So that's Java Runtime Architecture. To wrap up this one, we've seen the Java JVM, we've seen the compiler, we've seen the interpreter, we've seen the JVM, and we've seen the Java Runtime Architecture, and we've seen the bytecode, our Java Runtime. And now we've seen that the bytecode, whatever you guys do, sits on top of the runtime, our libraries, and that one sits on top of the Java virtual machine, and Java virtual machine sits on top of the computer hardware. So that's the structure, basic structure of the Java Runtime Architecture. Alright guys, that's it for this video. Thanks for watching. Don't forget to subscribe Wood. If you guys have any question or comment, leave in comment box. Otherwise, I'll see you guys in the next video, and bye.